So now we're going to look at some applications involving direct and inverse variation. We're going to be solving them by a 4-step process. The first 3 steps are the same as what we were doing just to come up with the equation of variation. And then step 4, we will use the equation we come up with to answer a specific question, to find some specific value. So let's look at some examples. At Larry's Lawn Service, the cost of lawn maintenance varies directly with the size of the lawn. If the monthly maintenance on a 4,000 square foot lawn is $280, then what is the maintenance fee for a 6,000 square foot lawn? So remember, these are the 4 steps that we're going to go through. Step 1, write the equation of variation using letters. So here, the cost of lawn maintenance varies directly with the size of the lawn. The cost is equal to K times the size of the lawn. So I wrote that as C equals K times S. You can use whatever letters you want. You can use X and Y or whatever, but I used C for the cost and S for the size. Step 2, plug in values for the variables and solve to find K. Okay, the monthly maintenance cost on a 4,000 square foot lawn is $280. 4,000 would be the size of the lawn, and 280 would be the cost. So let me put those numbers in, 4,000 for S and 280 for C. So 280 equals K times 4,000. Now to find K, we would have to go from K times 4,000 to just plain K by dividing both sides by 4,000. And 280 divided by 4,000 comes out as 0.07. 0.07. So that's our K. So let me go back and rewrite this equation, C equals KS, but instead of just using the letter K there, I'll put in the actual number, 0.07. So C equals 0.07S. Now we can answer the question, what is the maintenance fee for a 6,000 square foot lawn? Well, now we're putting 6,000 in for the size of the lawn. C equals 0.07 times 6,000. And that turns out to be $420. So the answer, $420. Next example. A software vendor sells a software package at a price that is inversely proportional to the number of packages sold per month. When they are selling 900 packages per month, the price is $80 each. If they sell 1,000 packages per month, what should the new price be? Remember our 4-step process. Step 1, write the equation of variation using letters. Okay, so they sell a software package as a price that is inversely proportional to the number of packages sold. So the price is inversely proportional to the number of packages. We have to write that in an equation. So how about this? P equals K over N. I used P for price and N for number of packages. Step 2, plug in values for the variables and solve to find K. When they are selling 900 packages per month, the price is $80 each. So I can put 80 in for the price while I put 900 in for the number of packages. 80 equals K over 900. Now to get K by itself, we have to undo the divided by 900 by multiplying by 900 on both sides of this equation. So when we multiply by 900 on both sides, 900 times 80 comes out as 72,000. So that's the number for K. And now if I go back and write this equation again, but put that number in place of K, here's what it looks like. P equals 72,000 over N. Now this is what we can use to answer this question. If they sell 1,000 packages per month, what should the new price be? We're putting 1,000 in for N, the new price. P equals 72,000 divided by 1,000. And that comes out to be 72. So the price, $72. Another example. The cost of material used in making a frisbee varies directly with the square of the diameter. If it costs the manufacturer 45 cents for the material in a frisbee with a 9-inch diameter, then what is the cost for the material in a 12-inch diameter frisbee? Step 1. Write the equation of variation using letters. So the cost of material varies directly with the square of the diameter. Careful, not the square root, but the square. What you get when you take that number and square it. So the cost of material equals K times the square of the diameter, the diameter squared. Using letters, I can write C equals K times D squared. Now, plug in values for the variables and solve to find K. The cost is 0.45 when the diameter is 9. So 0.45 equals K times 9 squared. 9 squared would be 81. So I divide both sides of this equation by 81. And K equals, well, 0.45 divided by 81 as a decimal is 0.005555 repeating. As a fraction, it's 1 over 180. So using that number in place of K, the equation is C equals that number, 0.005555 times D squared. Now the question, what is the cost for the material in a 12-inch diameter frisbee? If we put 12 in for the diameter, we're going to be calculating 0.005555 times 12 squared. And that comes out to be 0.8. And since we're talking money, how much something costs, it makes sense to give 2 digits after the decimal point. So I'm going to write that as 0.80, 80 cents or $0.80. And one more example. The weight, how much it weighs, of a cylindrical can of pea soup varies jointly, so there's more than one variable, jointly with the height and the square of the radius of the can. So when we write that as an equation using letters, the weight varies, so it's equal to K times the height times the square of the radius. So weight equals K times height times radius squared. W equals K times H times R squared. If a 4-inch high can with a 1.5-inch radius weighs 16 ounces, that means we're putting the number 4 in for the height, H, 1.5 for the radius, R, and 16 for the weight, W. 16 equals K times 4 times 1.5 squared. Now, if we calculate 4 times 1.5 squared, we get 9. 16 equals K times 9. And then divide both sides by 9. Well, as a fraction, it would be 16 over 9, or as a decimal, it would be 1.7777. So 16 equals K times 9. Divide both sides by 9. We get K equals 16 over 9, or 1.77777. So that's the number we put in place for K. W equals that number, 16 ninths, times H times R squared. Now to answer the question, what is the weight of a 5-inch high can with a radius of 3 inches? So if we put 5 for the height and 3 for the radius, that means W equals 16 over 9 times 5 times 3 squared. And when I calculate that, I get 80. So the weight would be 80 ounces.